Thank you so much, Ravi. I'm sure your session has a lot of takeaways for the brilliant audience here. Thank you so much once again. Ladies and gentlemen, can we have a round of applause for him? Our next session is going to be the story of a plantation, which is going to be taken forward by Jayant Swamy. The session will talk about how digital technologies and data analytics have helped our client achieve its vision in connected agriculture and forestry. Ladies and gentlemen, please put your hands together for him.
We're going to play a video. We're going to play a 3-minute video. This is, as Ravi talked about, everything is about the customer. And you'll see there are different types of customers. Let's see the video, and then we'll talk about, the story behind it and what it takes to make this come alive. It's a story about a plantation in a Southeast Asian country, and then we'll get into that a little bit more detail. If you can cue the video, that'll be great.
Largest, most technologically advanced and efficient makers of pulp and paper products in the world. April's core competencies of growing and harvesting trees are driven by sustainable practices and development. This is underpinned by a strong commitment to building capabilities and local communities, generating sustainable growth throughout the value chain. April's products make a difference to millions of lives every day, with products ranging from liquid packaging, printing and writing paper, tissues, shopping bags, food packaging, or magazines and books. April's flagship brand of paper, Paper One, is sold in more than 85 countries worldwide.
Major challenge facing April right now is that because new land development has finished, we have to get more wood production from the area we've got. This is absolutely essential so that April can grow its pulp and paper business.
RGE realizes that technologies such as digital can help improve operations significantly. Called the connected agriculture and forestry, digital technologies such as data and analytics, mobility and devices, and cloud and security will all play a key role in enabling April's vision for a connected future. On its connected agriculture and forestry, the digital transformation will enable the workers at all levels in the field to detect and be alerted on falling growth and challenges of pest or disease, receive intelligent and predictive plantation insights on the ground and in the air, have near real-time plantation and estate visibility produced digitally, obtain operational visibility at an activity or compartment level, and optimize wood supply and obtain cost transparency.
I think the first and biggest benefits of going digital is through the capture of the data, the downloading, and getting standardized reporting immediately out to all the people in the field, to those running the business and making the decisions.
The partnership between April and Accenture just started a couple of months back, and I like their approach of starting this project because they are investing about 12 weeks of their time just to understand the business prior the project started.
Jadi saya rasa selama kita terlibat di dalam proyek kerjasama Accenture dengan April ini, tim Accenture cukup kooperatif, mempunyai keinginan yang sangat besar untuk bisa memahami operasional yang ada di April, dan kita dari tim April juga berusaha semaksimal mungkin apa yang kita lakukan di lapangan juga bisa dipahami oleh tim Accenture.
The connected agriculture and forestry marks a world first for both RGE and Accenture, helping RGE build a business that improves lives, good for the community, country, and company.
Awesome. So, let me give you a story behind this. This is a great story of how we brought data and analytics together for Plantation. This client came to us about a couple of years back and said they had a plantation. Plantation is about 480,000 hectares, which is about 3 times the size of Singapore. So if you can visualize that size, it was large. Now they were doing this as with any other Southeast Asian country. They were managing this manually. So one of the key problems that they were facing was, insects and infestation. So they were losing close to 20% of their crop on an annual basis. By the time they found out where, if they had to go and manually inspect this entire large land, by the time they got to it, the plant was already gone. They were losing 20% of their revenue here, which is pretty big. If you think about it on a size of this size, on an ongoing basis, it's quite large. More importantly, they did not know where to go and look. So if they found something, it was almost by accident. So one of the key things, how are we going to solve this now? We could automate what they were doing manually, etc. We could do. So this is where we looked at what is the new available to us. How can we do it in a completely different manner? That is a very important aspect in this. How can you span, and they were taking 30, 35 days to do this. So we brought in drones. That's where we saw the whole concept of drones being brought in. The idea was to survey the entire land. We surveyed the land on a daily basis now. So when we started doing this, the amount of data that is coming in, video graphics that's coming in on a daily basis was tremendous. So now we are translating that data on a daily basis. That is one part. Second, we trained our machine learning algorithms to understand what an infected plant looks like. So when you go and look at it, inspect it manually by hand, it's one thing. So people who are experts understand that. But if you're looking at it from an aerial view, how do you recognize an infested plant? That was what we had to kind of understand and train our algorithms to understand. But once we did that, and it's a continuous learning process. It's not like I got it on day one and it worked like a charm. We had to train it over time. And we had to bring in experts. We had to bring in horticulturists. We had to get the local people there who understood those trees. And we got them to understand and identify those images, look for the special marks. Once we got that, then we were translating this video graphics in real time, identifying patches where we were starting to see the decay starting. So if you start to see a pattern in one area, idea is that it will spread in that area. So once we did that, you saw that we were now communicating once we identified it, we're communicating to the workforce on the field. So they knew where to go to. Now we are bringing this down from 30 days to 4 hours. So within 4 hours, they are able to get to where they need to be. This is the value of data being made real, right? If we are able to make it to an outcome, then it makes sense. If we are not able to convert that, collecting the data and storing it for a later time is not very helpful. Our ability to make it real is important. Now, as we went through this, I've talked about a few things here, which is one is the business was needed. I needed the horticulture people, the experts on the ground who had to identify it. But there's a lot of technology behind this. I talked about drones, IoT, which is, I needed communication. I needed that communication data to be transferred. Now, this data is being transferred at very high speed, very large amounts of data. Video information is very intensive, and especially I needed HD information because I need this data to be at very high resolution. So this data is being transmitted at very high resolution. I needed storage, cloud storage, at remarkably high, low latency to capture it, convert it, transform it into data that I could use. Then we had to run the machine learning algorithms on this. So we were able to then process and identify the areas in impacted land. So as you're seeing, I'm now spanning a few bands of technology and data and types of data architecture as well. And this is important because in the past, I would have most probably had a technical architect who would just look at a traditional architecture mode and look at it and say, you know what, I have my data tier, I have my application tier, I have my web tier, and that's how I would build out my applications. That's how we would build out most of our applications in a traditional way. We are now in a very different place where a lot of these are services that I may not even be having. I may be using a third-party service for some of these things, and which is what we did. And I myself built some of these, for instance, the video analytics is a service that Accenture built and is now using for our third parties as well. We provide that as a service for other services as well. So it is important that we architect these systems in a very structured manner and for us to be successful here. This was a project that was done in close to about 8-9 months. And it has been tremendously successful. We've brought that model to other places as well now. It has gone both the architecture and the model. But what I wanted you to kind of understand is when we started this, it was important that we understood the type of skills that we're going to need to make this successful. And that is, with that, I'll introduce another gentleman here to come on stage and talk to us about this kind of what it takes for us to build this kind of a skill set here. Because I didn't have this, when we started this project, I didn't have that skill set on my team. We had to build that as well. With that, let me introduce Nitin Sawant, who leads our technology architecture and data architecture here in Accenture. Welcome,
Hi.
Nitin.
Hi, Jayant.
So Nitin, you know, technical architecture has been around for years, right? And data architecture has been around for years as well. What do you see is changing, and in this in the context of this project, right? How do you see us evolving to build this new brand of data architects?
Yeah, so before I get to the question, right, I see this is a very, very serious data crowd here. What's so serious about it? I don't know. Right, so we had some break questions, quiz questions. I just wanted to ask a question, which I think both data scientists and data architects, and I'm making a strong statement there. I don't know which side of the room is data scientists and data architects. A question, has anybody heard of the word Moneyball? How many of you have heard of Moneyball? So you don't answer that. No, sorry. Right. So Moneyball, it's a book written by Michael Lewis, The Art of Winning an Unfair Game. That's not the question. The question is, which was the baseball team in that book?
It starts with A.
Yeah, it ends with an A, actually.
It starts with A, alphabet A.
It ends with an A.
I don't know if it ends with
Yeah,
A.
sorry. So we'll give it to him. So the team is Oakland Athletics. Please give the chocolate box to him, please. Right. So I think that's something which all data scientists here should be reading, because that's really an application of data science to a specific problem. Which to summarize that story, Oakland Athletics is probably in our Ranji Trophy equivalent of baseball is probably the Rajasthan team. I don't know. I'm just taking a name, not the Mumbai team. And how do they get those Mumbai type of players at the least cost, because they don't have too much money? So I think what Oakland Athletics did was really did an analytics of all the people, all the players available in the colleges and the schools. But that's where they identify the great potential players for the future. And they really did analytics and found out that these are the players and these are the characteristics of players who really become game winners later. Right? And that's the application of data for a specific problem. Coming to, again, Jayant's question, right? I'm sure many of you have done many Coursera courses on data science, MIT, Stanford's. How many of you have not done it? Very few have not done, right? So they are all learning on the job or been in data for long. Have you done a course from the University of Washington which talks about data science at scale? Which doesn't talk about any algorithms, which doesn't talk about all the machine learning cool things that you saw in the previous slides. It just talks about the scale of the problem and how do you architect your data model, right? Video analytics that Jayant mentioned requires a lot of really compute, storage, network, all of it. How do you really architect a data science solution when you're churning data at such a intense scale and all the traditional hardware, software out there is not really sufficient, and that's exactly what data architects do. Right? And I lead the technology architecture practice here in India, and we are really working closely with our data practice. We have Aarti Dev here who leads our data practice. So we work very closely as the engineering team or the architecture team to really make those solutions that you want really scalable and really implemented at that scale, because there's no point doing data science on a data of 1 gigabyte, 10 gigabytes, 100 gigabytes. That's not the size of data where you'll get insights with the algorithm that you're using. I think all of us agree here that. So there's one more question and one more prize there. How much is what do you call 10 raised to 24? This is all data guys, I assume, so you should all know without Googling. 10 raised to 24, anybody immediately? Gigabytes, terabytes, whatever bytes. 10 raised to 24 is yottabytes, right? So that the chocolate goes to me, right? So okay, 10 raised to 15. Petabytes, yeah. So one chocolate there, right? So I think that is the scale which data architects really are solving, and we at Accenture have a really global data architecture practice, right? So I lead the technology architecture, but Jayant is the global data architecture practice lead here, and we have a community of data architects who are not only just doing data science, but really understanding the problem in totality. So how do we implement it for this 5 times Singapore size plantation, right? And there's a certification program that all the data architects need to go through. There's a basic technology architecture certification, right, which tells you all the ELTs and the scale and the maintainability, the scalability, the security and all of that. And then how do you apply it to a data problem, right? So the digital security and cloud, all of them getting into solving this data problem for us, right? So I think that's the message that I wanted to give you, that as we build our careers in data, not just on the science part of it, which of course requires a lot of domain knowledge and industry expertise, but if you have a technology background there, really you should be looking at becoming data architects, who can then, because that's going to be the need, because I think as we say, keep saying, there are about, 121 algorithms out there? Maybe 122, I don't know. But then after a while, all of us here are going to know those 121 algorithms, right? What next, right? So it's going to be the industry knowledge and the ability to really scale your solutions to solve large problems. And I think that's where the importance of the data architect becomes really, really significant in solving all of these data issues that you're solving for your clients. And
so this is a critical point, right? I think we've all taken different journeys here, and you'll be hearing from Aarti a little bit as well. So we've taken a journey through a technical path into data. We've taken a journey through data, logical data into data. And one of the things that we're seeing is a coming together of all this. If you think about it from the perspective of, and you yourself have your own stories most probably as well. As we're coming, the time to get this done is becoming lesser and lesser. The demands that, if you put yourself in a consumer's shoes, we are expecting things to happen, we are expecting things to show up on our phones much faster, much sooner, which means I want to see the latest fashion trend that's happening there. I want that in my stores here, much more cooler, much more faster, much more recent, so that I can go have that experience sooner. So what does it take to make that? What used to take 6, 8, 10 months to happen, I want it in 2 months. What does that mean? If it has to happen in 2 months, I need to be able to do this, a large proportion of it. In anything like this today, technology is enabling most of it. And data is the core component of that thing. I think our ability to do that, for that, the skill set is going to be critical as we go through this next chapter of this thing. And that's what we are seeing. I'd love to hear from you. If you are seeing a story which you have, I'd love to hear that as well. But with that, I think we'll move to the next session as well. Any thoughts, any ideas? Please don't be shy. Raise your hand. It's supposed to be more of a sharing environment as well.
Yes, so does any of your organizations have any data Sorry.
There you go. There's
a question there, yeah.
So I recently worked on a project for one of the hospitality industry clients. We had a lot of data coming in. So the problem was, how do I price my hotel rooms in such a way that I have full occupancy, right? This is one of the critical problems that we have faced. So we had a lot of data coming in from different sources and vendors, like, Google gives you a lot of search history data. Websites like hotels.com, Pegasus, bookings.com, they churn a lot of data as well. And you could get the prices of each of those hotels online, like web crawling and stuff like that. So this huge amount of data has to be churned out, and we implemented a solution called as high performance pricing, where we had a lot of crunching to do and ultimately figure out, okay, for the facilities I have in my hotel, how competitive can I go, how low can I go to get this sold? So that is one interesting stuff that we worked on.
Very good. I'm sure there were some sleepless nights there, where you were...
It took about a year and a half for us to completely deliver that.
Fair enough. Good. I'm sure it's a great experience as well. I'm sure there are other... So definitely those scars of that that experience will be there. But please wear them with pride, and we'll love to hear. So thank you for sharing that as well.
Thank you.
Nothing to contribute. I just wanted your opinion, but you were mentioning about the 122 algorithms. Could you maybe put some more light on that, please?
No, that was just a statement to say that after a time, everybody else will know all the algorithms that need to be known.
Okay.
Right, so 121 was a random number, it could be anything. Right, so I think that's the message where we really need to be, as you said, need to be worried about the scale at which we need to be solving these problems.
So, but when you hold on to that question, because I think you will hear some of that as well, because it's not the algorithm which is, we are building new algorithms generally, but you will find that the implementation of these algorithms, in fact, some of the algorithms which are in use today are actually quite old. Some of the very common ones are in fact 300 years old. So, if you've heard of the Bayes theorem that's being done, that's being used very aggressively in this area, that's about 300-400 years old. So it's not, the algorithms are not new, it's the technologies which are now enabling the usage of these is making it tremendously more potent actually, I would call you almost that in that sense. So with that, we'll move to the next session.
Thank you.
Thank you.
Thanks.
Thank you so much.